All right, let's look at circular motion. So circular motion is just like kinematics and dynamics. We're looking at basically things like velocity, acceleration, and forces. Now, if we look at the basic equations, let's go through them. For velocity, basically v is equal to d over t. The difference is, in this particular case, your displacement is a circular path. If you remember circles, that's 2 pi r. So you go around once, so the perimeter is 2 pi r divided by t, or the time it takes to do one rotation. That means this is not a small letter t, this is the large letter t for period, right? So it's the time it takes to do one full cycle, 2 pi r divided by t. We could go through how the other equations are derived, but we can just kind of, to keep things short, we can realize that acceleration, therefore, is going to be related to changes in velocity. That's related again to that video that I had the other day where there's a triangular relationship. So it's a little bit more tricky to explain, but the short answer is AC is equal to V squared over R. The other one can be derived 4 pi r squared divided by large T squared, okay, or period. So if you take a look here, that gives us 3 equations. Now, obviously, this equation here could provide data here, which is where this one came from. And again, this one was derived from the triangular relationship that we looked at in the first video. Now, if we think of force, force is pretty straightforward. Force is mass times acceleration. Here's our acceleration, our centripetal acceleration. So really, these are your 2 equations for centripetal force. So we'll call that Fc. We should put a little c there for centripetal velocity. There is no equations for these ones here because you simply expected or assumed that you can derive this from that relationship there. So those are your 3 key equations, and again, we could go so far as to say those are some expanded equations. So there are 5 equations that you're going to work with here in centripetal motion. All right, so let's go over some sample questions. Right, so you're going to have your formula sheet. You're going to need that, and you're going to need a calculator. So let's find a practice question to start with. All right, let's look at a car. So we have a car traveling in a circular path. We'll say that the car's got a velocity of 100 kilometers per hour, and let's give this a radius to keep it simple. A radius of 100 meters. Right, so we're going to go through, see what variables we have. So I know 100 kilometers per hour is 27.7 meters per second. So I didn't have to do that conversion. If you don't know how to do that conversion, you have to figure it out. And then the radius is 100 meters. One of the tricky things here is be careful. Diameter, radius, those are 2 different measurements. Obviously, we're always working with radius. Going to my formula sheet, the question might be, of course, what's the centripetal acceleration? And again, I can see that that's a pretty straightforward equation. AC is equal to V squared over R. So 27.77 meters per second squared divided by 100 meters. Right, I'm going to grab my calculator, crunch these numbers. And we get 7.7117. 3 significant digits, 3 significant digits. Therefore, my answer is 7.71 meters per second squared, which is perfectly reasonable. Less than gravity, less than 1 g of force. Now, let's do another example with something a little bit trickier. All right, let's look at a harder example. So, let's take a look at a vehicle with a truck tire spinning. Right, so what kind of centripetal force could this tire generate? Well, we need some basic information. So a truck tire could have a mass of 40 kilograms. It's got a spin at about 100 kilometers per hour. this thing is going to be spinning, and we often use a number or revolutions per minute as a reference of 840. So it goes around 840 times a minute when you drive it at 100 kilometers per hour. The last thing we're going to need to know is the tire size. And tire sizes usually go by rim size. So R16, R15, R18, and that is basically a measure of the radius. So we'll assume that that is for 16-inch rims, so that would make this roughly a 32-inch tire. Now obviously we've got to convert that. So which works out to just shy of 1 meter. So let's keep it at 1, but we should give ourselves 3 significant digits, but our mass is limited to 2, so our final answer should be 2 significant digits. So we have a radius, RPMs, which we're going to have to work with, and mass. We look at our two equations. We've got v squared over r. I don't see how we're going to have v squared. The other one is 4 pi squared r over t squared, which is period. RPMs is going to be able to give us that information. So that's what we're going to have to work out, and that makes this a tougher question. So it takes 60 seconds to revolve 840 times. But I don't want to know 840 times. I want to know how much time it takes to do 1. So what we see here is we've created a ratio, and we should understand how to do cross multiplication. To get this value here, we would take 1 times it by 60 divided by 840. If we do that math, we get a value of 0.071428. So again, we'll carry at least 4 digits, and that becomes our t, large T period. So that's the time it takes to do 1 revolution. So 840 in 60 seconds, 1 in 0.07 seconds. All right, now I have M, R, T. So based on those numbers, I should be able to solve for FC. FC is your 4 pi squared r, and then again, mass, because we're looking for force, divided by t squared. From here, it's just plugging in the numbers. Mass of 40 times 4 times pi, you should have that in your calculator, squared, times the radius of 1.00 meters, divided by my period of rotation, which is 0.0714 seconds squared. Crunch those numbers, and we should get a really big number. Obviously, I'm going to have to get this down to 2 significant digits. So that's going to be 3.1 times 10 to the 5th newtons. Now, what this means is when your tires are spinning, they generate a lot of force. This is gyroscopic force, and it's one of the reasons why a vehicle in motion is a little bit more stable and basically travels in a straight line. Well, there you have it. I've done a couple examples. Obviously, you might have issues with different questions, and so go over the questions there in the practice section. If you have any problems, let me know which question in particular, and I can kind of work through that question for you to give you a little bit of help. But here are 2 examples, one that was kind of relatively easy, one that was obviously more complex that had RPMs, so you had to figure out what the period is. Hopefully that helps. Good luck with practice questions, and let me know what you need help with. Talk to you later.